Most of us have done perimeter and area before, and so we worked on this a little bit yesterday. I want to remind you that perimeter, to get the perimeter, it is the distance around a figure. Distance around a figure. So, if you have 3 sides for a triangle, how will you get the perimeter? William, how would you get the perimeter to go around a triangle? Bristol?
You have to add the side 1, 2, and 3.
You would have to add side 1, side 2, and side 3. What if I had a rectangle, Mason? If I were measuring all the way around? Emily, do you know?
For the perimeter, yeah, you would add all sides.
You would add all sides. So this is the base, this is the height, this is the base too, and this is the height too, because they're the same since it's a rectangle. So my perimeter on this would be H plus B plus B, right? Mm-hmm. And so I could also write that as P equals, there are 2 H's, 2H plus 2B. Now you don't really have to memorize any formulas for perimeter, do you, William? Because you can just think of what you would do to go all the way around the figure. Yes, Bristol?
Whenever I need my notes, you can print them out.
It's okay. It's okay. Thank you, though. All right. So you don't really have to memorize it because all you have to know is that we're measuring going around a figure. What kind of units? Do I use regular units, square units, or cubic units?
Square.
For distance around?
Oh, no. You do that for area.
I would do that for area. But if I were doing just measuring distance, I'm going to use my ruler, right? Now, if I were measuring a square, I would use square units, wouldn't I? If I were measuring the area of it, how much space it is on the inside, I would have to use a square. Now, the big thing that's different about this and what you've always done before, Fletcher, when you do the homework, make sure you're doing this, okay? When we are doing this, we're going to include the units while we measure something. So if I wanted to do, let's say I wanted to do something that is 5 centimeters, and this distance is 8 centimeters. How would I write that? Fletcher, can you tell me how I would write this? P equals
8 centimeters plus 5 centimeters. Then would be P equals...
Well, wait a minute. I've got to do all 5 of them, don't I? 8 centimeters plus 5 centimeters plus what is this distance?
8 centimeters.
Plus 8 centimeters plus 5 centimeters, right?
Yeah.
So but what I really want to see is I want to see that you're including those centimeters in there. Okay? Now, if I were to take a ruler and I were to add all of those centimeters, here's a ruler. I have 8 centimeters plus 5 centimeters, and I'm going to go off the chart here, plus it would be 8 centimeters plus 5 centimeters. What would I come up with? What would I come up with, Emily?
8 centimeters divided by 8 centimeters?
No, I'm not going to divide it. I'm going to add them all. So I'm going to, and what do you think is the easiest thing to add here, Brian?
26 centimeters.
Yeah. Add 5 plus 5.
Add the 5s to get 10.
And 8 plus 8.
8 plus 8 is 16. So you get 26, but I still have centimeters. And you saw that when I did this on a ruler, I can add 8 centimeters here, plus 5 more centimeters. It's still going to be centimeters, isn't it? Okay, if I were going to do the same thing, Mason, do you understand this now? If I were going to do the same thing for area, I would get area. What's the form? Anybody remember how we get area? Emily?
You multiply the base times the
Base times the height. That's for a rectangle. Now, if it were a square, let's look at that. If it were a square, this is the base and this is the height. But what else do we know about a square, Bristol? Are all 4 sides the same?
Oh, yeah.
So couldn't I say that this height is really the same as the base? So I could say that the area of a square is base squared. But you know what? You don't even have to memorize that formula. Why do you think you don't have to memorize that formula there, Mason? What do you think, Ashana? Why do I not need to memorize the formula for a square?
because I'm pretty sure you already know what to do.
Because you already know how to do a rectangle. And so you could memorize this formula, or you could use just this one that you already know. And then you would say base times height. And it's just that both of these numbers will be the same. So you don't really have to memorize a lot of formulas, do you? Okay, but the key thing I want you to remember, let's go back to this one where we had 5 centimeters by 8 centimeters. And let's think about something. What did I just say? 5 centimeters by 8 centimeters. That you hear those dimensions a lot on things like wood or how big a room is, right? Like the room is 12 feet by 14 feet, right? So how do I get area for that room?
You do 8 times
I do.
base times height.
Base times height. Whenever you see this by like that, if you say something's 5 by 8 or something like that, what are we always going to do, William? Whenever you see by, like when we're talking about dimensions of a room, 8 by 5, we'll multiply, won't we? You see that, right? So that'll help you with problems besides just this one, won't it? Okay, so my area equals base times height. Now here's the place that I think people get confused between what I want and what they've done before. Okay, before people have just done 8 times 5 and said area equals 40. Or they might have even just looked at it and been able to show, oh, it's 40. But Fletcher, that's not what I want. What is it that I'm looking for? What do I want to put instead of base here?
You put, 8 centimeters.
8 centimeters times 5 centimeters. I don't want you to wait till you get to the end and just add units here. Does that make sense, Mason? Okay. So what you're going to do is you can also say this as, we could do it in any order. 8 times 5 times centimeters times centimeters. Isn't that kind of interesting? Then we get 8a equals 40. What's centimeter times centimeter? What would that be? That's centimeter squared. Now, I am not going to require that you write that step. You don't have to write that step, but you do need to think it in your head. You can just do this and multiply your 2 numbers first and get your 40, and then multiply your units and get your square centimeters or centimeters squared. So Fletcher, if you are not putting that centimeter in all the way through the problem, it would not be right. Does that make sense to everybody? Okay. The other thing that I want you to know, the only other thing we did yesterday is we looked at a rectangle. This is a rectangle. And the area, oh wait, it's not showing up? Okay, wait a minute, no, hang on. This, wait a minute, it's okay. I'm trying to, it won't write, hang on.
It's what you see
I know. Here, let me just draw it first. Okay, so I have this rectangle, okay? And I'm going to show all of you my rectangle, right? How did I figure out the area of a triangle yesterday? What did I do with this rectangle?
You cut it in half.
I cut it in half to make...
Right?
You are right.
I just guessed.
I cut it in half to make 2 triangles.
I'm half a boy.
So here's one triangle. Here is the other triangle. You guys in the classroom all see the triangles, right?
Yeah, baby.
Now they're the same shape, aren't they?
Yeah.
So I can take this triangle and put them on top of each other. So if that rectangle, if that's my whole area, how much is the triangle's area? Half of that rectangle, isn't it?
Yeah.
So what is this value, right? What is the value? Whoops.
Whoa.
Okay. What is the value of this, the bottom edge? What is that? What do we call that?
2.
That's the base, right? This bottom edge right here. This is the base. What was this side part here?
Height.
This was the height. Now, we already said that the area of a triangle is going to be half as much as the area of the rectangle. The area of the rectangle, half of that, 1/2 base times height. We can write it that way. Who's seen it written another way? Another formula. Area equals base times height over 2. Have you seen that?
I've seen that.
They're both the same. Do you know why they're both the same? Brian, why would these be both the same? Why are these 2 formulas the same thing? Why are they the same thing? If I do 1/2 times base times height, isn't that this?
Oh my goodness.
Now, I'm going to multiply all these things on top. I'm going to multiply 1 times
B.
base times height. What will that give me?
It will give you 1. Wait, no.
No,
it
no,
will
no.
give you
Brian's doing this one, okay?
And then, oh, I'm Brian.
Brian's going to do it.
It'll give you B and A.
It'll give me base times height on the top, and what will it give me on the bottom?
2.
I multiply those, and I get 2. So you see, this is exactly the same as this. You may use one of those formulas if you like one better. You may use the other formula, or if sometimes you like one and sometimes you like the other, that's fine too. I will accept any of those ways of doing the problems. So that is what we did that was new yesterday. And when you give your answers, when you go over your problems, when you're writing them down, I want to see these steps with the centimeters or whatever the units are all the way through the problem. So you're not going to do it like this. You're going to do it like this so that I can see that you know how to operate with the units. Why is that important? Those of you who are in 8th grade, what subject have you taken that all these units are really important?
Physical science.
Physical science, absolutely. Have you done that in biology as well?
Not really.
Not yet?
Biology.
Well, wait till chemistry, because I promise you'll do a lot of it in chemistry, won't you? You even do this in geography. You need to be able to you need to do unit conversions, right? So you'll even do this in geography. So it's important that you understand how the units work.